Lesson 18, Least Common Multiple and Greatest Common Factor. Goal, find the least common multiple and greatest common factor of two or more numbers. Vocabulary, greatest common factor of two whole numbers, A and B. Written GCF, AB is the greatest whole number, which is a factor of both A and B. So when we find the greatest common factor, we're looking for a factor that two numbers share, and it needs to be the greatest of all of their common factors. Least common multiple of two non-zero numbers A and B, written LCM as A, comma B, is the least whole number, larger than 0, which is a multiple of both A and B. So when we think about multiples, we are going to be multiplying numbers, and we want the least common multiple. This is helpful when we try to find common denominators. We would be finding the least common multiple of two numbers. So for our lesson, I'm going to show you a couple different ways to find LCM and GCF. The good thing is you get to choose which of these ways works for you. I used to be a big proponent of the factor trees. Now I like a different method best. But we're going to go ahead and start off with the listing, which might be the way that you have seen before. This is a common method. This could take kind of a long time. So this is the downside of the listing, is that sometimes it could be one of the first couple ones you list. But for other numbers, you could be listing a lot of numbers to finally get a common factor or a common multiple. So if I list factors, the question here is, what is the GCF and LCM of 12 and 18? So I would write down 12, and I would write down 18. So the factors, if you want, you can go through 1, 2, 3, 4, 5, 6, and keep going, or you can try to find pairs. So I like to do pairs, so I know 1 and 12 will go together. The next number is 2. I know 2 and 6 go together. The next number is 3. 3 times 4. And because there's no numbers in between 3 and 4, I know that I probably have them all. So again, 1 and 12, 2 and 6, 3 and 4. If you list your factors, you want to make sure that they all pair up with a number. Okay, sometimes people forget one because they're not making sure that they have counted them all together. The factors of 18, 1 and 18, 2 and 9, 3 and 6. In between 3 and 6 would be a 4 that does not go in evenly, 5 does not go in evenly. So these are all of the factors. So now what I would do, I circle the common factors. They share 1, they share 2, 3, 6, and no other number. So the greatest of them would be the 6. That would be the greatest common factor. Now I want to list the multiples. Another downside of listing is that you have to have two separate lists. Because we have a list of factors, now I'll have a list of multiples. Again, I want to write down 12 and 18. And for these, I like to kind of go, keep them kind of even. So 12 times 1 is 12. 18 times 1 is 18. So now if I multiply 12 by 2, I get 24. This one would be 36. And then 12 times 3 is 36. So I like to kind of, again, keep them even. That way I don't have like 10 multiples of 12 when I really only needed 3, and then I needed 2 there. So this one, we came to 36 was our first common multiple, and that's the least of the common. There would be more, but you, again, want the least common, the smallest number that they both have in common. So the GCF is 6, the LCM is 36. Okay, the other two ways here, we have factor trees and we have upside down division. This is also called maybe upside down birthday cake or the L way. There's a couple different names for this one. Both of these kind of do 2 for 1. So the the way that you are going to solve, you're going to be able to find your GCF and LCM with doing it one time, whereas again with the listing you had to have two separate lists. So let's look at factor trees. So I'm going to do a factor tree for 12, I'm going to do a factor tree for 18. And with factor trees, the nice thing is you don't have to know all of the factors. You can just think of two numbers that you can multiply together to make the numbers. So with 12, I can pick 2 and 6. You can also pick 3 and 4. You cannot use ones. No ones in our factor trees. We need prime numbers when we do factor trees, and 1 is neither prime nor composite, so that's why you can't use 1. So 2 is prime, so I'm going to circle it, but 6 has more factors, 2 times 3. These numbers are prime, so now I will circle them, and I just circle to indicate that that tree is done, that branch. For 18, I could do 2 times 9, or 3 times 6. This is prime. The 9 is not prime, composite, so 3 times 3 makes the 9. Those are prime numbers. So now what I do when I'm done is I list 12, I list 18, and all the numbers I circled, I'm going to put them in numerical order and write them down. So 2 times 2 times 3. And when I multiply 2 times 2, I get 4. 4 times 3 is 12. When you do your products, when you multiply, you need to get 12 as a product. So 18, I'm going to have 2 times 3 times 3. Again, 2 times 3 is 6. 6 times 3 is 18, so that is correct. So that would be my prime factorization of 12 and my prime factorization of 18. Now that I have those numbers, what I do is I circle the groups that are in common. I have a group of 2. I'm going to write that down once. And the 3s, I write that down once. What they have in common, I multiply together just one time, one of the numbers, 2 times 3, and I get 6. This is my GCF. However, there are numbers that do not get pairs. There's not a pair with the 2 and not a pair with this 3, a second pair. So for LCM, you're going to take your GCF 6. You're also going to multiply by all of the numbers that were not originally circled. So times 2 times 3. When I do this, 6 times 2 is 12, and 12 times 3 is 36. Or you could do 2 times 3 is 6 times 6 is 36. And that will give you your LCM. So again, take your GCF number, write that down, but also add in the numbers that did not have a pair. Okay, the numbers that I say were left out. We don't want them to be left out of the group. We include them in LCM. That is a way where you're using prime factorization to get GCF, but also using that GCF to get your LCM. The last way is the upside down division. This is my personal favorite. It didn't used to be because I didn't really understand it until I used it multiple times, and then I finally got comfortable with it, and now it's my go-to method. So what you're going to do is put 12. You can put it with separate it with a comma with the 18. You don't have to put a comma here. You could just have enough space so you know there's 2 separate numbers. So what you're going to do is just going to think of a number that you can divide into both of these numbers. Try to think of the largest possible number if you can. So let's just say that I only know that they're both even and that 2 goes into those numbers because I'm using divisibility rules. Now I'm going to divide 12 divided by 2. So it's kind of like division, but the division box is upside down, and that's, again, why it's called upside down division. So 12 divided by 2 is 6. I'm going to write 6 underneath. 18 divided by 2 is 9. Now, I take these two numbers and I think, can I divide those by any number? Is there any number, common factor, that those two numbers share? And yes, there is. I could divide by 3. Take a different color. I'm going to put my 3 on the outside, and I'm going to divide 6 by 3, which is 2. Divide 9 by 3, which is 3. And then again, I'm going to ask, does 2 and 3 have any common factors other than 1? And these are both prime numbers, so the only common factor they would have is 1. When that happens, you are totally done with trying to divide the numbers. So what you would do is you would multiply any and all numbers that are on this left-hand side together to get your GCF. 2 times 3 is 6. 6 is your GCF. Okay? However, we also want to find LCM. And for LCM, L is the shape that we're going to make with these numbers right here. Makes an L. So that's why sometimes it's referred to as the L way. And that's why we do it upside down, because when we do it upside down, we make an L. And L stands for LCM. So what we do is we actually multiply all of the numbers that are inside of this L. So we know these two numbers make 6. We're also going to multiply by 2 and also by 3. So if this makes 6, 6 times 6 is 36. And we would have 36 for the LCM. So this is pretty similar to here, where we took our GCF and multiplied by 2 times 3. But there's just a bunch of other numbers involved in this process here, where this one is a little bit simpler. And again, you don't have to know all of the factors. You just have to know one number that you can divide into it. And let's say I knew that I could divide by 6. Then I would just have 6 on the outside, one number. If I just have one number, that is the GCF. And again, I can make my L and multiply 6 times 6, or 6 times 2 times 3, and I would still get 36. So you can find the GCF, just one number, and that alone would be your GCF. But if not, you would have to multiply any of the numbers you list to the left, and that straight line going down would be your GCF.
Rate yourself. How do you feel after watching the video? Please write green, yellow, or red on the left-hand side of the page under the page number. Second thing I want you to do is write a comment or question you have about GCF or LCM. Number 3, create your own question and provide the answer if you are agreeing.